CC 615 Cloud Infrastructure Week 5 Infrastructure Services and Cloud Architectures Part 3. Single server. The most basic use of the cloud is to provision a single virtual server running your application along with supporting service applications such as database. Although a single server is not much of an architecture, it can be used in a proof of concept projects to get your first experience with a particular cloud provider and to see how easy and how fast the provisioning process is. Single server with services. Instead of packing everything into a single server, a cloud consumer can take advantage of services available from the cloud provider. Here we illustrate the use of firewall service and database service. The provider will be responsible for creating the services and keeping them running. The cloud consumer needs to populate and administer the data in the database service. To accomplish this, the cloud consumer's database administrator will access the database server using a virtual private network or VPN connection over the internet to ensure security. The application server will run the business application and will connect to the database service via a private network within the cloud provider's data center. Application with security zones and on-premise IT connectivity. For large databases, proprietary data storage solutions, or databases unsupported by the cloud provider, the data can be stored in a separate database virtual server. The cloud provider will maintain the server but not the database. Because businesses value their data as their most precious commodity, they will want to secure it by isolating it from the public internet. This can be accomplished by placing the database server in a separate private VLAN or a separate subnet in the same VLAN as the application server. These VLANs or subnets will enforce security zones for their devices. They will be made available to the outside by using network gateways, an internet gateway for the application server and a VPN gateway for the database server. Also, a network address translation or NAT gateway between the security zones will make sure that only trusted traffic can pass between them. Such gateways are often offered as a service by the cloud providers. This architecture is illustrated in the figure on this slide. The VPN gateway for the database server can connect it to the on-premises enterprise network of the cloud consumer for taking on-premise backups or integrating the cloud solution with the on-premises systems, enabling hybrid cloud deployments. Load balancing, auto-scaling, and database replication. User loads placed on web applications can differ significantly depending on the time of the day, week, year, or any other circumstances. To remedy that, cloud providers offer auto-scaling services. The cloud consumer can define an autoscale group, specifying a lower and upper limit on the number of servers in the group, the machine images from which the servers are provisioned, and circumstances leading to up or down scaling in the group. These can be based on calendar or use of network bandwidth, CPU, or memory on the servers. In order to split the incoming requests among the servers, a load balancing service directs the requests to the members of the group based on server use or various other queuing algorithms. This architecture is illustrated in the figure on this slide. The database server can be duplicated, which requires keeping copies of the database in sync. A preferred solution is to have one master database server with a slave database server using the database provider's replication and synchronization capability. It ensures the fault tolerance with respect to the database. Fault tolerance and high availability. The concept of replication can be extended to the application servers, providing for a cloud deployment that is fault tolerant with respect to all servers and ensuring availability in situations such as natural disasters or other circumstances that would cause the whole data centers to go offline. In addition, the application and databases can be replicated to different geographical regions, ensuring fast access from remote geographical locations. And replication can help satisfy local government regulations regarding data privacy, which may require the user data to reside within the specific region. See this figure for illustration of fault tolerance and high availability architecture. fast delivery of static content with object storage and content delivery network. While dynamic application data has usually to reside on a database server or service, static content such as text, graphics, video or audio that doesn't change that often can reside in a slower but less expensive storage media. For that purpose, cloud providers offer object storage, which can be thought of as an internet-based file system, allowing for storage of objects organized into containers in a geographically distributed, replicated and secure storage. While not at the speeds of local storage, object storage offers fault tolerance, resilience and virtually unlimited capacity, at the cost of data consistency being eventual rather than immediate. Data stored in object storage can often be served by content delivery networks, or CDNs, a service which allows for geographically distributing data and serving it from the closest geographical location to the place from which the data request originates. Object storage with content delivery network architecture is illustrated on this slide. Some of the architecture components illustrated here can be mixed and matched. For example, the autoscale groups and the replicated databases can be placed in security zones, and VPN gateways can link different servers to corporate on-premises networks. In summary, this week you learned about application programming interfaces in general and infrastructure as a service APIs in particular, as well as about infrastructure as code. You also learned about some auxiliary services in cloud environments such as security, monitoring cloud deployments and database services. You have also learned about typical cloud infrastructure as a service architectures such as single server with services, application with security zones and on-premise IT connectivity, load balancing, auto-scaling and database replication, fault tolerance and high availability, as well as fast delivery of static content with object storage and content delivery network. We hope that those architectures illustrated all the concepts covered in the previous weeks. Thank you.